For this next example, we have volume, we have temperature and pressure at SATP, which is 25 degrees Celsius and 100 kilopascals. The temperature we're looking for, and the gas expands to a new volume and a final pressure. So in this case, I have temperature, pressure, and volume all fluctuating. There's no mention of mass or number of moles, so I'm still assuming that N is constant. This means we need to use the combined gas law, which is P1V1, P2V2, looks like Boyle's law, over T1, T2. I'm solving for final temperature. I'm solving for T2. So remember with our gas laws, if we're looking for temperatures, a quick way to save some time when we're rearranging is to flip our equation. So if I'm isolating T2, I need to cancel out P2 and V2. So again, we always do the opposite thing. So right now I'm dividing by P2 and V2, so I can multiply by P2 to cancel, and also multiply by V2. I need to do the same thing on this side. So I end up with T2 equals P2 V2 T1 all over P1 V1. If we sub in our numbers, my P2, my final pressure, this is P2, is 98 kilopascals. My final volume is 0.950 liters. My initial temperature, it started at SATP, so that's 25 degrees. Remember, we have to add 273 to convert that to Kelvin. We get 298 Kelvin. Divided by an initial pressure, it's at SATP, so my initial pressure is 100 kilopascals. And my initial volume, right now I have my volume in liters, so this volume also needs to be in liters. So remember, to convert from milliliters to liters, we move our decimal 3 spaces. To the left, we're dividing by 1,000, so we get 0.125 liters. Check your units. You're going to have kilopascals over kilopascals will cancel, liters over liters will cancel, and we're left with Kelvin, our units for temperature. So when we multiply this all out, we end up getting an answer of 2,219.5 Kelvin. If I want to look at significant digits, I need 2 based on my original data that I'm given in the question. So I need to put this in scientific notation. So move your decimal 3 spaces. We get 2.2 times 10 to the power of however many places we move the decimal, which is 3. So I get 2.2 times 10 to the 3 Kelvin. If you sub this in your calculator and you did not get this, it's probably because you didn't put this in brackets. So because I have multiple terms in the denominator, this has to go in brackets, 100 times 0.125, when you enter that into your calculator.